Okay, children, now we are going to the 20th question in 2023 May-June paper. That is about the barium chloride can be prepared by the reaction of barium carbonate with hydrochloric acid. So they have given the reaction barium carbonate and HCl, that it makes barium chloride, carbon dioxide and water. So let me to write that equation in the board. First we will write that equation in the board. Right, this way. So the equation is, yeah, barium carbonate is a solid, so I put here S, and that it react with 2HCl. HCl is aqueous, right, gives barium chloride BaCl2, that is aqueous, plus carbon dioxide plus water. Water is a liquid. Carbon dioxide is a gas. Right. Write ionic equation for this reaction. State symbols are not required. Even though it says state symbols are not required, I have always advised you that don't write the ionic equation without state symbol, because in the case of identification of what we call spectator ions, state symbol is very important. So I will do this example with the state symbols. Right. Now, barium carbonate, BaCO3. I can't divide this because it is not dissolved. So barium carbonate, I write that barium carbonate like this way. Barium carbonate, we have to write this BaCO3, that is a solid, plus HCl is aqueous and dissolved. So then HCl is dissociate to 2H plus aqueous ions and 2Cl minus aqueous ion. Right. For my easy, I will write it like this way. Then the barium chloride. See the state, that is aqueous. So then BaCl2 aqueous finally makes Ba2 plus aqueous ion. Aqueous means, children, that it dissolves, right? Dissolve means that it separates into their ions possible. So barium chloride is dissolved, that means Ba2 plus aqueous and 2Cl minus aqueous. Carbon dioxide is a gas, so I have to write it like this. Water is a liquid. We concern water is not dissociated. Now, why I separate that dissolved thing? Why I always separate that aqueous thing? You know, in a sodium chloride solution, that aqueous solution of sodium chloride no longer contain NaCl together. They are no longer contain NaCl together. They always separate Na plus signs and Cl minus sign. That's what the meaning of dissolve, right? So therefore, now we have to recognize the spectator ions. See these 2Cl minus aqueous, and this side 2Cl minus aqueous. They are spectators. We cancel off them. So then what remains? Barium carbonate. Such a thing is not there in the other side of the arrow. So can't cancel off. 2H plus. It's not the 2H plus in the same way. That means it reacts. That means I can't cancel it. So it is H2. I can't cancel with that 2H and this H2 plus. And then the carbon dioxide gas cannot be cancelled off. So then I will write that ionic equation now. That is BaCO3, which is a solid, plus 2H plus, which is aqueous, gives what? Ba2 plus aqueous plus CO2 gas plus H2O liquid. So this is what the ionic equation for this reaction. Right. So that's what the ionic equation for this reaction. Right? So I guess you understood how do we write the ionic equation. Right. I quickly go to the next part of the question. The second part of the question is a 2-mark question. It says that calculate the atom economy by mass for this preparation of barium chloride. Calculate the atom economy by mass for this preparation of barium chloride. So what we want to find? We want to find the atom economy, right? We'll see that atom economy. What is that atom economy is, right? Atom economy. So first of all, I will write this equation, that is BaCO3 solid plus 2HCl gives BaCl2 plus carbon dioxide plus water, right? BlCl2 is aqueous, carbon dioxide is a gas, water is a liquid, and this is aqueous. What they ask, calculate the atom economy for barium chloride. So what is atom economy equation? You need to remember this atom economy equation, right? Atom economy is atom economy is equal to mass of atoms of desired product divided by mass of atoms of all the reactants, all the products, multiplied by 100, right? Okay, what is the mass of the atoms of desired product? Barium chloride is my desired product, right? So barium, what is the value of barium? Barium is 137. Chlorine, there are two chlorine, so it is 35.5 plus again 35.5. The total mass will be 208.3. It says 137.3, right? So the answer is mass of the barium chloride is 208.3. It is 208.3 is the total mass of my desired product divided by mass of atoms of all the products. What is all the products means? This one, carbon dioxide and water, all the three. So what is that is that 208.3 is anyway there. Carbon dioxide is 44. Oxygen is 8, water is 18. So multiply by 100. So the calculator will give a value that's very easy, 77.063%, like answer will be there. So this is mass of the desired products atom. This is the mass of all the products multiplied by 100. That is what the atom economy is, right? That's what the atom economy is. So then I go to the next one. We did that atom economy equation, right? So now we go to the next part of that. Barium chloride, next question. Barium chloride has a melting temperature 962. Cesium chloride has the melting temperature 646. Explain why considering the ions, that's important, ions involved, the difference between the melting temperature of the period 6 chloride. Right, we'll see that. Okay, so this question is regarding barium chloride and cesium chloride, right? So what is that? Barium chloride, how do you write the barium chloride? BaCl2. That melting point is 962. Cesium chloride is CsCl2. Melting point is 646. So these are the MP means melting point. So why that barium chloride has high melting point? Why the cesium chloride has less melting point? Right. Melting point determine how strong a lattice they make. You know, barium chloride, right? You know, this barium chloride is ionic compound. Cesium chloride also ionic. So how do we find the strength of ionic lattice? To find the strength of ionic lattice, there's an equation. Strength of ionic lattice let it to be F. F is equal Q1 into Q2 divided by D to the power 2. Q1 means charge of the cation, right? Q1 is charge of the cation. Q2 means charge of the anion, right? When the charges are greater, F is high. That means higher charges make strong attraction. And the D is the distance between the two nuclei, right? The distance between the two nuclei. If the distance, I mean the radius, ionic radius, not the atomic radius, no atoms there, ions there. When the atomic radius small, the small atomic radius, this is +2 and this is, say this one is -2. When the small atomic radius there, now their attraction is stronger because they are very close now. So smaller the size, right? Smaller the size, higher the attraction. Higher the charge, higher the attraction. So when I consider barium, barium is 2 plus charge, right? When I consider cesium, cesium is 1 plus charge. So in the case of charge, who is higher? Barium. That's why the barium chloride melting point is high. In the case of radius, lower the radius, higher the attraction. See the barium has lower radius than the cesium. This is what the cesium is. Right. You remember that in the barium, cesium in this way across the period radii decreases. So cesium in the group 1 and the next this is cesium and this is barium. If you see the periodic table, you can understand. Right. So we see that barium is smaller in size. Cesium is bigger in size. The smaller in size barium, so radii decrease. So the attraction increase. That's why the melting point of that one is high. Right. So when we write the answer for that, you want to pay attention for these points. What are the points? Barium has higher charge of +2. Cesium has lower charge of +1. Therefore, electrostatic attraction, very important that word, electrostatic attraction, no sharing, not just attraction, no polarization, those are rejected answers. Electrostatic attraction is higher because the charges are higher in the barium. The radius is less in the barium. Therefore, the electrostatic attraction is higher in barium chloride, right? So, more energy, that point is the last point. Most of the students forget to write that. More energy is required to break that barium chloride lattice than that of cesium chloride lattice. That is why the barium chloride has high melting point, right? I think that you understood the explanation, right? So barium chloride has higher melting point. The 4 points are there. First one, barium is smaller in size, cesium is bigger in size. So the attraction high in the barium chloride. Barium +2, cesium +1. So the attraction is high in barium +1, barium +2. So barium chloride. So the electrostatic attraction, the word important, electrostatic attractions are stronger in barium chloride than that of cesium chloride. So to overcome the attractive forces, electrostatic attractive forces, to overcome those things in barium chloride need to give high energy, so the melting point is high. Right. I go to the next point. Now the next part of the question, the fourth part of the question, right? The fourth part of the question is something like this. This says that covalent and ionic bonding are extremes of continuum of bonding type. Explain the difference in the bonding between the barium chloride and beryllium chloride using the electronegativity values shown. Using the electronegativity values shown. Right. We'll see that part. Right. It's something like this. They are asking about barium chloride. Barium chloride. Right. It's like this way, barium chloride. And the beryllium chloride also like this way. When I consider one of these bonds, barium value is 0.9, right? Chlorine value is 3.0. So the difference between the electronegativity difference is 2.1. Right? Beryllium is 1.5, chlorine is 3.0, right? Chlorine is 3.0. So difference here, the difference is 1.5, right? Those things we can get from the table given. Now I will recall the theory lessons that we discussed. We concern hydrogen and hydrogen. Hydrogen is 1.2 and hydrogen is 1.2. What is the difference? 0. Electronegativity difference is 0. So we call it is non-polar covalent. Non-polar covalent. If the electronegativity difference is 0, non-polar covalent. For an example, chlorine and chlorine. Chlorine is 3.5 and this chlorine is 3.0 and this chlorine also 3.0. Difference also 0. So chlorine is non-polar covalent. But if I go to HCl, HCl is 2.1, sorry, hydrogen is 1.2 and 3.0. So the difference is high, right? So it is around 1.8 like. So it is called what? Polar covalent. Polar covalent. We discussed that if the difference is 0, non-polar covalent. If the difference is between 0 to 2.1, polar covalent. If the difference is more than 2.1, if the difference is more than 2.1, ionic. So when I concern the electronegativity difference, right, we say En difference, electronegativity difference. If the electronegativity difference is 0, is what? Polar covalent. PC means polar covalent. 0 to 2.1, sorry, if the electronegativity difference is 0, non-polar covalent. 0 to 2.1, polar covalent. More than 2.1, ionic. So see that in the barium chloride, the difference is 2.1. So it is ionic. BeCl2's one at one bond. In BeCl2, one bond is difference 1.5. So it is covalent. So it's less ionic, more covalent. Right? Understand that? So therefore, I can say that explain the difference in the bonding between the barium chloride and beryllium chloride using the electronegativity values. How do we use the electronegativity values? We use the electronegativity values for barium chloride. See this, barium chloride, difference is 2.1. So I said as the difference is 2.1 or more than that, it should be ionic. So this compound is almost ionic. And here the difference is 1.5. So it is less than 2.1 and greater than 0. If it is that 0 to 2.1, PC means polar covalent. 0, non-polar covalent. More than 2.1, ionic. So this is ionic. This is polar covalent molecule. Is it clear? Oh, sorry, bond. This bond is polar covalent, right? Explain the difference between the bonding between the barium chloride and beryllium chloride using the electronic. So this bond is polar. This bond is uh, ionic. Almost it is ionic. Clear? Right. That depends on the electronegativity difference. If the electronegativity difference is 0, we call it is non-polar covalent. 0 to 2.1, polar covalent. More than 2.1, ionic. Right. I go to the last part of that section. Right. So we see the last part of that question. There's a 4 marks calculation part. So we see that what that 4 marks calculation part is. Right. So this question says us barium chloride reacts with the group 1 sulfate M2SO4. M2SO4 plus barium chloride gives barium sulfate and MCl. A solution is made by dissolving 7.98 grams of group 1 sulfate in deionized water. Excess aqueous barium chloride is added to this solution and the precipitate is filtered, dried and weighed. The mass of the barium sulfate precipitate is 10.72 grams. Identify the group 1 element. Right. It's like this. Let me write the equation first. Right. This time MSO4. This time MSO4 plus M is the group 1 element plus BaCl2 gives BaSO4 plus 2 MCl, right? So our question is actually what is this M? That's what we want to find last, right? Anyhow, in this one that a solution is made by dissolving 7.98 grams of group 1 sulfate. This is the group 1 sulfate. I have 7.98 grams of that is added to barium chloride, right? BaCl2. So then it finally makes the barium sulfate. Precipitate is barium sulfate. That's what this. So this is the mass of this barium sulfate precipitate. It is 10.7. 10.72 is the mass of barium sulfate precipitate. Right. Using these facts, I want to find what is this M is. Right. See the way I do it. Barium sulfate mass is given. That they says that filtered and dry. So only the barium sulfate is there. Dry means even no water there. So pure barium sulfate mass is, I know the barium sulfate mass. Barium sulfate mass is how much? 10.72. Oh, I don't like the mass. I want to convert that into moles. So I can write barium sulfate moles. 10.72 divided by barium sulfate. How do we get that barium sulfate moles? It is 233.4. That is 233.4 is the molecular mass of barium sulfate. So I got the number of barium sulfate mole is how much? 0.045 moles. 459 moles. So I know the barium sulfate moles. See that? I know the barium sulfate moles. Barium sulfate to M sulfate is 1:1 according to this. Here is M2. Let me get. Barium sulfate to M sulfate is 1:1 is the ratio. So how many barium sulfate moles there are? Same M sulfate moles. So I said M2 sulfate moles should be how much? 0.0459 moles. Okay. Then, oh, that's easy then. Next. Now you know moles equal mass over molecular mass. I know the M sulfate moles. How much? 0.0459. 459 is equal mass. Mass of that also known. How much? 7.98. 7.98. Molecular mass is a thing that I don't know. Right? So I subject that molecular mass. I'll bring it this side. So the molecular mass of that it is equal 7.98 divided by 0.0459. So the answer is 38.8, or the answer is almost 39. So what is 39? See the periodic table. See the periodic table. What is 39 in the periodic table? 39 is potassium. The answer is what then? Potassium. So we got the identity of the substance, potassium. 4 marks question. The first mark is given. I will show you the places where the marks allocated. Finding the molecular mass of barium sulfate. This part individually earn 1 mark. Right. The next one, calculating the moles of barium sulfate, 1 mark. Right. Taking the ratio 1:1 and determine M2 sulfate also the same amount, the 3rd mark. And this whole calculation, the 4th mark. So that's how the 4 marks are allocated. So I guess that that question also very much clear to you. With that, we have end that 20th question. So I will end this video also. We will go to another question with another video. Thank you.